Network types. It's often useful to group networks according to the physical distances they cover, although the characteristics that define each group are becoming increasingly blurred as communication technology advances. Networks are generally divided into. There are different types of network: local area networking, wireless local area networks, wide area networks, metropolitan area networks, campus area networks. Local area network. A local area network defines a configuration found within a single office building, warehouse, campus, or similar computing environment. Such as a network is generally owned, used, and operated by a single organization and allows computers to communicate directly through a common communication line. Examples ng local area network amin siya. A bridge is a device and the software to operate it that connects two or more geographically distant local area networks that use the same. For example, a simple bridge could be used to connect two local area networks that use the Ethernet networking technology. Muna siya an example sa bridge. What is gateway? Gateway is a more complex device and software used to connect two or more local area network or system that use different protocols. A gateway will translate one network protocols into another, resolving hardware and software incompatibilities. For example, the system network architecture, commonly called SNA, gateway can connect a microcomputer network to a mainframe host. Ang high-speed LAN naman have a data rate that varies from 100 megabits per second to more than 40 gigabit per second naman. Metropolitan area network. A metropolitan area network defines a configuration spanning an area larger than a LAN, ranging from several blocks of buildings to an entire city but not exceeding a circumference of 100 kilometers. For example, New York City. Amin siya ang New York City and may office building, university campus, government building, residential area. And sa New York City, naga-provide sa free Wi-Fi access to all residents as a large single MAN. Wide area network. A wide area network defines a configuration that interconnects communication facilities in different parts of the world or that's operated as part of a public utility. WAN use the communication line of common carriers, which are government-regulated private companies such as telephone companies that already provide the general public with communication facilities. For example, including each branch offices and ATM machine is another example of an organization using a wide area network. The branches may be in multiple U.S. states or even global location, but they are all linked through various secure connection. Both bank employees and customer are users. Wireless local area network. A wireless local area network is a local area network that uses wireless technology to connect computers or workstation located within the range of the network. An example sa wireless local area network is home or office Wi-Fi networks.
Network topologies. Sites in any network system can be physically or logically connected to one another in a certain topology. The geometric arrangement of connections, cables, wireless, or both, that link the nodes. The most common geometric arrangements are star, ring, bus, tree, and hybrid. In each topology, there are trade-offs between the needs for fast communication among all sites, the tolerance of failure at site or communication, communication link, the cost of long communication lines, and the difficulty of connecting one site to a large number of other sites, it's important to note that the physical topology of a network may not reflect its logical topology. For example, a network that is wired in a star configuration rather can be logically arranged to operate as if it is a ring. That is, it can be made to manipulate a token in a ring-like fashion even though its cables are arranged in a star topology. To keep our explanation in this chapter as simple as possible, whenever we discuss topologies, we are assuming that the logical structure of the network is identical to the physical structure. It's quite possible that there are several possible solutions for each customer. The best choice would need to consider all of all four criteria. For example, an international data retrieval company might consider the fastest communications and the most flexible hardware configuration to be cost-effective investment. But a neighborhood charity might put the most emphasis on having a low-cost networking solution. Over-engineering the neighborhood system could be just as big a mistake as under-engineering the international customers network. The key to choosing the best design is to understand the available technology as well as customers' business requirements and budget. Star parts of the topology. A star topology, sometimes called a hub or centralized topology, is a traditional approach to interconnecting devices in which all transmitted data must pass through a central controller when going from a sender to a receiver. Star topology permits easy routing because the central station knows the path to all other sites and because there is a central control point. Access to the network can be controlled easily and priority status can be given to selected sites. However, this centralization of control requires that the central site be extremely reliable and able to handle all network traffic no matter how many heavy. Star topology. In the star topology, each device in the network is connected to a central device called hub. The devices can communicate directly. They can communicate without the devices through the hub. Advantages of star topology. Less expensive because each device only needs one input and output port to connect to the hub. Less amount of cables required because each device needs to be connected with the hub only. Robust, if one link fails, other links will work just fine. Easy fault detection because the link can be easily identified. Disadvantages of star topology. If hub goes down, everything goes down. None of the devices can work without hub. Hub requires more resources and regular maintenance because it is a central system. Ring. A ring network can connect to other networks via the bridge or the gateway depending on the protocol used by each network. Or the protocol is the specific set of rules used to control the flow of messages through the network. If the other network has the same protocol, then a bridge is used to connect the networks. If the other network has a different protocol, a gateway is used. Data is transmitted in packets that also contain source and destination address fields. Each packet is passed from node to node and in one direction only, and the destination station copies the data into a local buffer. Typically, the packet continues to circulate until it returns to the source station where it's removed from the ring. There are some variations to the basic topology, such as the double loop network shown in figure 9 to 5 and a set of multiple rings bridged together.
Ring topology. In ring topology is the device connected with two devices on the other side of it. The structural form of ring is known as ring topology. Each device ring topology has repeated in the device swarms to presented to the another device, then it sends to one direction if device wants to send it to the device 5. It feels send to the device 2 if we send it to the other device the feature until the device rather. Advantages of the ring topology. Ring topology is easily to install. Managing is the easier as to add or remove a device from the topology. Only two links are required to be changed. Disadvantages of ring topology. A link failure can fail the internetwork as the signal will not travel forward. Data traffic is more since all the data circulating in a ring.
Bus. In the bus topology, all sites are connected to a single communication line running the length of the network. Devices are physically connected by means of cables that run between them, but the cables that don't pass through a centralized controller mechanism. Messages from any site circulate in both directions through the entire communication line and can be received by all other sites.
Bus topology. In bus topology, there was a backbone cable and all devices are connected to this backbone rather cable through drop lines. Sensor the main cable there are limited drop line and the distance the main cable can have. Advantages of bus topology. Easy installation since each cable needs to be connected with backbone cable. Less cable required than mission to start topology. Disadvantages of bus topology. Difficult to detect any fault. Not scalable as there is a limit of how many nodes you can connect with backbone cable. If the backbone cable fails, the complete network crashes.
3. The tree topology is a collection of buses. The communication line is a branches cable with no closed loops. The tree layout begins at the head end, where one or more cables start. Each cable may have branches that may in turn have additional branches, potentially resulting in quite complex arrangements. Using bridges as special feeders between buses of the same protocol and as translators to those with different protocols allow designers to create networks that can operate and at speeds more responsive to the hosts in the network. In a tree configuration, a message from any site circulates through the communication line and can be received by all other sites until it reaches the endpoints. If a message reaches and an endpoint controller without being accepted by a host, the endpoint controller observes it isn't turned around as it been using a bus topology. One advantage of bus and tree topologies is that even if a single node fails rather, message traffic can still flow through the network.
main bus, and you can see there are hubs, and those hub computer connected in star condition. The combination of two topology is also known as tree topology. Now it is used in WAN, that is called wide area network. Easy expansion of node, that means you can easily connect to a lot of devices, that is the maintenance. This network is very easy, but it's also central hub dependent, that means if min was failed, all the network fail.
Hybrid. A hybrid topology is some combination of any of the four topologies discussed here. For example, a hybrid can be made by replacing a single host in a star configuration with a ring.
Hybrid topology is a combination of two or more topology is known as hybrid topology. For example, a combination of star topology and ring topology is a hybrid topology. Advantages of hybrid topology. We can choose the topology based on the requirements. Scalable, as we can further connect other computer networks with existing networks with different topologies. Disadvantages of hybrid topology. Fault detection is difficult, installation is difficult.
This is the continuation of Chapter 9, Network Organization Concept. I will going to discuss the software design issues, addressing conventions, routing strategies, connection models, so on and so forth. First, let's discuss about the software design issue. So far, we've examined the configuration of a network hardware component. In this section, we'll examine four software issues that must be addressed by network designers. First, how do sites use addresses to locate other sites? Second, how are messages routed and how are they sent? Third, how do processes communicate with each other? And fourth, how are conflicting demands for resources resolved? So paano nga ba nalalaman ng isang site ang isa pang site sa pamamagitan lamang ng addresses or IP address? At paano nga ba nagta-travel ang message at paano ito na-receive? So ngayon, samahan niyo akong alamin ang mga ito. Una na nga dito ay ang addressing convention. Ano nga ba ang addressing convention?
Addressing conventions. Network sites need to determine how to uniquely identify their users so they can communicate with each others and access each other's resources. Names, addresses, and routes are required because sites are not directly connected to each other, except over point-to-point links. Therefore, addressing protocol are closely related to the network topology and geographic location of each site. In some cases, a distinction is made between local name, which refers to the name by each unit is known within its own system, and global name, the name by which a unit is known outside its own system. Sa addressing convention ay hindi ito kagaya ng tao na nalaman natin kung sino ang tinatawag natin o gusto nating kausapin. Ang computers ay nagre-rely sa kanilang address name, ruta o kaya naman ay kanilang domain name. Example of addressing convention.
The domain name system. What is domain name system?
The Domain Network System or DNS, a protocol helps internet users and network devices discover website and using human readable host names instead of numeric IP addresses. Sa pamamagitan ng DNS or Domain Network System, ay nagkakaroon ng convenient at human readable hostname ang mga computer kumpara sa dati na kailangan mo pang i-type o isulat ang IP address ng isang website. Sa pamamagitan ng DNS, ginagawa niyang readable ang hostname. At the same time, tinatranslate niya ito into numeric or binary. We already know that computers can't understand human words. Instead, they rely on numbers or binaries. For more explanation about DNS, let's watch this.
In the world of networking, computers don't go by names like humans do. They go by numbers. Because that's how computers and other similar devices talk and identify with each other over a network, which is by using numbers such as IP addresses. Humans, on the other hand, are accustomed to using names instead of numbers. Whether it's talking directly to another person or identifying a country, place, or thing, humans identify with names instead of numbers. So in order to bridge the communication gap between computers and humans and make the communication a lot easier, networking engineers developed DNS. And DNS stands for Domain Name System. And DNS resolves names to numbers. To be more specific, it resolves domain names to IP addresses. So if you type in a web address in your web browser, DNS will resolve the name to a number, because the only thing computers know are numbers. So for example, if you wanted to go to a certain website, you would open up your web browser and type in the domain name of that website. So for example, let's use yahoo.com. Now technically, you really don't have to type in yahoo.com to retrieve the Yahoo web page. You can just type in the IP address instead if you already knew what the IP address was. But since we are not accustomed to memorizing and dealing with numbers, especially when there are millions of websites on the internet, we can just type in the domain name instead and let DNS convert it to an IP address for us. So back to our example, when you type in yahoo.com in your web browser, the DNS server will search through its database to find a matching IP address for that domain name. And when it finds it, it will resolve that domain name to the IP address of the Yahoo website. And once that is
Router. Router is a device that connects two or more packet switch networks or subnetworks. It serves two primary functions. First, managing traffic between this network by forwarding data packets to their intended IP address. Then, allowing the multiple device to use the same internet connection. Nakakita natin ang router sa piso Wi-Fi area or even sa private Wi-Fi. Ano nga ba ang gamit ng router? Ang router ay may dalawang pangunahing function. Una dito ay nagmamanage ng traffic between network and data packets. Then at the same time, ang pangalawa is allowing multiple devices to use the same internet connection. Routing Information Protocol. In Routing Information Protocol or IIP, selection of a path to transfer data from one network to another is based on the number of intermediate nodes or hops between the source and the destination. The path with the smallest number of hops is always chosen. This distance vector algorithm is easy to implement, but it may not be the best in today's networking environment because it does not take into consideration other important factors such as bandwidth, data priority, or type of network that is can be included faster or more reliable paths for being selected just because they have more hops. RIP or stands for Routing Information Protocol. Ito ay ang selection ng mga data path na kung saan ang may maliit lamang na numbers of hops ang kanyang inuuna at napipili. Kaya sa panahon ngayon, hindi na ito masyadong magagamit. Dahil sa panahon ngayon, karamihan ng mga users ay gumagamit na lang ng more numbers of hops katulad na lang ng mga share it at Bluetooth nowadays. Kung mapapansin mo, ay kaya nilang mag-send ng mga files sa isang minuto. Open Shortest Path First or OSF. A selection of a transmission path is made only after the state of a network has been determined, so that if an intermediate hop is malfunctioning, it's eliminated immediately from consideration until its service has been restored. Ang open source path first naman Ito ay ang seleksyon ng mga data na kung saan nag-a-access lang ito if na-determine niya ang network na kinakailangan. Ngunit, pag nagkakaroon ng isang malfunction, otomatikong Now, what is connection models? A communication network isn't concerned with the content of data being transmitted, but with the moving data from one point to another, because it would be prohibited to connect each node in a network to all other nodes. The nodes are connected to a communication network designed to minimize transmission costs and to provide for connectivity among all attached devices. Connective modules have two types. First is circuit switching. Circuit switching is a communication model in which a dedicated communication path is established between two hosts. The path is a connecting sequence of links and connection between 2 points exists until one of them disconnected. The connection path must be set up before data transmission begins. Therefore, if the entire path becomes unavailable, messages can't be transmitted because the circuit would not be completed. The telephone system is a good example of a circuit switch network.
Sa circuit switching ay kung saan nagkakaroon lamang ng transmission between two hosts or ang caller o receiver kapag ang data ay nasabay sa setup of transmission. If nagkakaroon ng disconnected wherein hindi mo na marireceive ang message or hindi mo na masisend. Kung makikita mo sa illustration sa taas, ang circuit switching ay nagkakaroon lamang ng selection of path between two hosts kung saan ang napiling data path ay nagtransmit ng data patungo sa destination. Ngunit kapag may isa sa kanila ang disconnect, otomatikong nagsasara at nawawala ang data o kaya naman ay di maipasa o ma-receive ng receiver.
Second is the packet switching. Packet switching is basically a store and forward technique in which a message is divided into multiple equal size units called packets, which are then sent through the network to their destination where they reassemble into their original long format.
Packet switching naman, ito ay nag-i-store at nagpo-forward ng message at dinidivide niya ito into a multiple equal size na kung saan tinatawag na packets. Ang packets naman, ang kanyang pangunahing gampanin ay nagre-reassemble ng original long format. Makikita mo sa illustration sa packet switching galing sa caller to receiver na kung saan ang data na kanyang itinatransmit ay hinahati-hati into equal size at inilalagay ito sa packets. Ang packets naman, ang kanyang pangunahing gampanin ay nagre-reassemble ng mga message into.
There are two different methods of selecting path. First, data graphs and virtual circuits. In the data graph approach, the destination and sequence of a number of packets are added to the information uniquely, identifying the message to which packets belong. Each packet is handled independently and a route is selected as each packet is accepted into the network. Conflicting resolution. Because a network consists of devices sharing a common transmission capability, some methods to control usage of the medium is necessary to facilitate equal and fair access to these common resources. First, we will describe the medium access control techniques, round-robin, reservation, and contention. Then we will briefly examine Three common medium access controls protocols used to implement access to resources: carrier sense multiple access or CSMA, token passing, and distributed queue dual bus or DQDB techniques. In networks, round robin allows each node on the network to use the communication medium. If the node has data to send, it's given a certain amount of time to complete the transmission, at the end of which the opportunity is passed to the next node. If the node has no data to send, or if it is complete transmission before the time it's up, then the next node begins its turn. Round robin is an efficient technique where are many nodes transmitting over long period of time.
Access control techniques. Ang access control techniques ay gumagamit ng round robin na kung saan nag-aalaw ang isang node to use the communication medium into another node. Kung saan kapag ang isang node ay mayroong data, ay natatransmit niya lamang ito in just a certain of time. Then, ipinapasa niya ito into another nodes, then another nodes to another nodes. At kapag ang nodes naman ay naipasa niya na ang data, babalik naman ito sa simula.
The reservation techniques. The reservation technique is well suited for a lengthy and continuous traffic. Access time on the medium is divided into slot and a node. Can serve future time slots for each use. The technique is similar that we found in the synchronous time division multiplex, used for multiplexing digitalized voice stream where the time slot are fixed in the length and pre-assigned to each node.
Ang reservation techniques naman, ito ay ang lengthy at continuous traffic na kung saan na-access niya ito into medium and divided into slots and nodes na kung saan sa mga synchronous time division multiplexing or ginagamit sa multiplexing digitalized voice stream na kung saan pinipix nito ang length at ina-assign ang nodes.
The contention techniques. The contention technique is better for a short and intermittent traffic. No attempt is made to determine whose turn it is to transmit, so nodes compete for access to the medium. Therefore, it works well under the light to moderate traffic, but performance tends to break down under heavy loads.
Ang contention technique naman ay mas mainam lamang gamitin para sa mga short at intermittent traffic. Kasi kapag ginagamit nito sa mga heavy loads, nagkakaroon na ito ng breakdown. Kaya mas mainam kung gagamit ka ng contention techniques, dapat isaalang-alang mo ang data na iyong itatransmit.
The CSMA, or the Carrier Sense Multiple Access, is a contention-based protocol that's easy to implement. Carrier Sense means that a node on the network will listen to or test the communication medium before transmitting any messages, thus preventing a collision with another nodes that currently transmitting. Carrier Sense Multiple Access or CMA/CE with a collision avoidance. Collision avoidance means that the access method prevents multiple nodes from colliding during transmission. However, opinion on its efficiency is divided. Some claim it's more efficient than collision detection.
Carrier sense multiple access. Ang carrier sense multiple access naman, ito ay nagkakaroon ng test communication na kung saan ina-assign or nag-a-assign ang mga nodes kung sino ang mauna. To avoid collision and at the same time, para na mas madali ang kanilang message transmitting.
Whereas other contend that is low as a network perform when there are large number of nodes. Token passing. In a token passing network is a special electronic message called a token. Is generated when the network is turned on.
and then pass along from node to node. Only the node with a token is allowed to transmit, and if it is done, so it must pass the token to another node. This network typically have either a bus or ring topology, and are popular because access is fast and collusion are non-existent. Ang token passing naman, ito ay a network, especially electronic message na kung tinatawag ay token. Ito ay nag-generate lamang kapag ang network ay naka-on. Then, ang token ay pinapasa sa node to node. If ang isang node ay may token, inialaw niya itong tinatransmit, then pagkatapos ay pinapasa ang token to another node. So, vice versa lang po siya.
A station is authorized to send data whenever it receives a special frame called a token. Whenever a station is holding the token, it means it's the turn of that station to send the data. So this token is a special frame. We will see about the special frame, that is the token, shortly. Then is there anything like a master here? So there is no master kind of approach here. So everybody is equal in this network. So here there is no master node. And what is this special frame? A small special purpose frame, which is known as a token, is exchanged among the nodes in some fixed order. So there will be a fixed order that is maintained in the network, and these tokens are exchanged among the nodes in that order. When a node receives a token, it holds on to the token only if it has some frames to transmit. Otherwise, it immediately forwards the token to the next node. Whenever a node receives a token, it holds the token and then it starts transmitting the frame. If that station has no data, it immediately forwards the token to the next node. We will see more on token passing. The previous point we saw, if the node doesn't have any frame, it has to forward the token immediately to the next node. What if the node has some data and it also holds the token? If a node does have frames to transmit, when it receives the token, it sends up to a maximum number of frames and then forwards the token to the next node. And this token passing is decentralized. As I already mentioned, there is no master in the scheme. So this token passing is not a centralized approach. It is a decentralized approach. It's highly efficient in terms of collision because there will not be collision in the scheme. The station which holds the token only is going to send the data. But it has some problems as well. Let's see what are the problems. For example, the failure of one node can crash the entire channel because these tokens have to be exchanged among the nodes in some fixed order. What happens if a node fails? That node only have to transmit the frame to the next node. So if a node fails, then it can crash the entire channel. Or if a node accidentally neglects to release the token, it means deliberately that station is holding the token for a long time. What happens? Other stations will be waiting indefinitely for this token. Again, this is a problem. Then some recovery process.
Token passing have two types. Token bus. In a token bus network, the token is passed to its node in turn. Upon receipt on the token, a node attaches the data to it to be transmitted and send the packets containing both the token and the data to its destination. The receiving node copies the data, adds the acknowledgement, and returns the packet to the sending node, which then passes the token onto the next node in logical sequence.
I have here a simple illustration of a token bus.
Another one is the token ring. Token ring is the most widely used protocol for ring topology. It became better known than token bus. When IBM made its token ring network commercially available, it's based to use token that moves between the nodes in turn and in one direction only. When it's not carrying a message, the token is called free token. If a node wants to send a message, it must wait the free token to come by It then changes the token from free to BC and sends its message immediately following the BC token. Ang mas kilala na protocol sa ring topology at mas kilala ito kaysa token bus. Ang token ring ay nag-a-assist ng token to the nodes turn in and only in one direction. So ibig sabihin, kapag ang isang token ay hindi nagdadala ng message or data, ay tinatawag itong free. So, if kinakailangan ng node na mag-send ng message or data, kinakailangan niya munang kinakailangan ng nodes na mag-send ng data, kailangan niya munang antayin ang token from free to BC kasi hindi maita-transfer ang message kapag ang token ay free. So kailangan niya muna maging busy so that sabay silang dalawa. I have here a simple illustration for a token ring. DQDB or the distributed dual bus. A protocol intended for use with a dual bus configuration, where each bus transports data in only one direction and has been standardized by one of the IEEE committees as a part of its MAN standard. Transmission on each bus consists of steady stream and a fixed size slot as shown in a figure 9.13. Slots generated at one end of each bus are marked free and sent downstream where they are marked busy and written by the nodes that are ready to transmit data. Nodes read and copies data from the slots which then continue to travel toward the end of the bus where they dissipate. Transport Protocol Standard. Transport Protocol Standard during 1980s network uses began to grow at a fast pace, as did to need to integrate the similar network devices from different vendors, a task that became increasingly default as a number and complexity of a network device increased. Soon the user community pressured the industry to create a single universally adapted network architecture that would allow the true multi-vendors interoperability will review two models, OIS and TPC/IP. OIS refers model that International Organization for Standardization OSI reference model or also called Open System Interconnection. The OSI have 7 layers. First, the physical layer. I only have here an illustration of 7 layers of OSI. Layer 1 or the physical layer, wherein the mechanical, electrical, and functional specification its main concern. It's concerned about its hardware. An only example for this is 100 base.T RS449 and CCITT-B.35. Layer 1 or the physical layer, wherein the mechanical, electrical, and functional specification its main concern, or its concern about its hardware. Only example of physical layer are 100 base-T RS449 and CCITT-B.35. Layer 2 or the data link layer. In this layer, its main concern are the data of the software itself, wherein the software must be stored in a programmable device such as a front-end processor, network nodes, or microcomputer. The example of this are HDLC, or also called the High Level Data Link Control, and SDLC, or Synchronous Data Link Control. The port layer or the transport layer, also known as the host-to-host or end-to-end layer. It's maintain readable data transmission between end user. A program at the source computer can send a virtual communication to a similar program at a destination machine by using message headers and control message. Layer 5, or the session layer. It's responsible for providing a user-oriented connection service and transferring data over a communication line. It provides a user interface that adds value to it. This layer are also called data flow control. It's also functioning as accounting to ensure the user receive their bills or requests. The third layer, or also called the network layer, its main purpose was to provide service such as addressing and routing that move data to the network to its destination. Layer 6, or the presentation layer, is responsible for data manipulation functions common to many applications such as formatting, comprehension, and encryption. Data conversion, syntax conversion, and protocol conversion are its own common tasks. The last layer of the OC model is the application layer. Its main purpose was for application program, terminals, and computer access the network. File transfer and email are two of the most common application protocol and its function. That's all the 7 layer of OC model. Now let's go to TCP or IP model, or stands for what is ISO? The International Organization for Standardization, or ISO, which makes technically recommendation about data communication interface. Talk on the task of creating such a network architecture. Its effort resulted in the Open System Interconnection, or the ISI, reference to model which served as a framework for defining the service that a network should provide to its users. This model provides the basis of connecting open system for distributed application processing. The word open means that any two systems that conform to the reference model and the related standard can be connected regardless.
Testing processes, working conditions, societal issues, and so much more. For instance, the ISO 31000 standard provides principles and frameworks for managing enterprise risk, which you can learn more about in the link above and in the description below. The ISO is a non-governmental organization comprised of more than 160 countries, with one standards body representing each country. For example, the American National Standards Institute represents the United States. ISO standards are developed in a 6-stage process, and ISO members vote on approvals. The ISO then sells documents detailing these standards. Being ISO certified means a business assures a service, product, or system meets the requirements of the particular ISO standard. But the process of getting certified can be expensive, time-consuming, and potentially disruptive to the business. Some reasons to pursue ISO certifications include regulatory requirements, commercial standards, customer requirements, quality assurance, and international customer satisfaction. Some of the most popular ISO standards concern security policies and processes and security management and business continuity. Specifically, ISO 9000 is a series of standards that defines how to establish and maintain effective quality assurance systems for manufacturing and
TCP/IP model, or the Transmission Control Protocol Internet Protocol. Reference model is probably the oldest transport protocol standard. It's the basis for internet communication and is the most widely used network layer protocol in use today. It was developed for the U.S. Department of Defense. ARPANET and provides reasonable, efficient, and error-free transmission between different systems. Process or application layer. The process or application layer is equivalent to the presentation and application layer of the OC model. It includes protocol for computer-to-computer resources, sharing and terminal-to-computer remote access. A specific example of standard set by the DoD for this layer are file transfer protocol, a simple application for transfer of ANSI, ABCDIC, and binary files. Simple Mail Transfer Protocol or SMTP, a simple electronic mail facilities and telnet, a simple asynchronous terminal capability that provides remote logon capabilities to user working at a terminal or a personal computer. Internet layer. The internet layer is equivalent to the portion of network layer of the OC model that isn't already included in the previous layer, especially the mechanism that performs routing functions. Therefore, this protocol is usually implemented within gateways and hosts. An example of a standard set by the U.S. Department of Defense. Host-to-host layer or host-host layer is equivalent to the transport and session layer of the OC model. As its name indicates, this layer supports the mechanism to transfer data between two processes on different host computers. Services provided in the host-to-host layer also include error checking, flow control, and ability to manipulate connection, control signals. An example of the standard set by the DoD is the Transmit Control Protocol or TPC, which provide a reliable end-to-end data transfer service. Network access layer. The network access layer is equivalent to the physical data link and a part of a network layer of the OC model. Protocols at this layer provide access to a communication network. Some of the functions performed here are flow control, error control between hosts, security, and priority implementation.
Network communications involves a suite of protocols known as the Internet Protocol Suite, or more commonly known as the TCP/IP Protocol Suite. This protocol suite includes all the protocols used in various aspects of end-to-end network communications, including addressing, routing, and reliability. The TCP/IP protocol suite is also a conceptual model that classifies and organizes the various protocols into 4 different layers: network access, internet, transport, and application. The transport layer includes 2 protocols: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. These protocols determine how the data will be delivered, reliably or unreliably. It is up to the network application to choose. If the application chooses TCP, the data will be delivered reliably, with guaranteed delivery and assembled in the proper order. Or it can choose UDP, when the data needs to be delivered as quickly as possible, with some tolerance for loss of data. TCP adds some overhead, which means there will be some additional delay. For example, the network application HTTP uses TCP to make sure all the data is delivered reliably. Here the user types in the URL www.mybank.example. TCP is used to transport the information reliably between the user's computer and the web server. The web server, also using TCP, sends the requested data, the web page, in separate segments. Each segment includes a sequence number so the receiver knows if anything is missing, and so it can assemble it in the proper order. UDP is a simpler protocol used to send data as quickly as possible, even if some data doesn't get delivered. Network applications, such as those used for sending voice and real-time video, can sacrifice some data loss in order for the data to be delivered as quickly as possible. As you can see, UDP does not include any functions for reliability, such as there are no sequence numbers in the UDP segments. To summarize, the applications such as those that perform file transfers, downloading web pages, and email all use the Reliable Transport Protocol TCP, whereas UDP is used for applications such as real-time video and voice, where speed is more important than reliability.